So how did that fit? Okay. All right. So today we're going to look at this box and whisker plot, which I think you've learned before, which deals with the median. So let me read this here. So the standard deviation, which we know how to find now, is a great way to measure the distribution of the data when the data is normally distributed. Okay? If the data is skewed to the left or to the right, meaning the numbers are a little spread out or maybe more towards the high numbers versus whatever. Okay, then the 5-number summary, which is this, which we'll plot as the box and whisker, then the 5-number summary describes the data a little bit better. Okay, so the 5-number summary involves the following values. You got the lowest number, you got the highest number, you got the median. By the way, how do we find the median of a set of numbers? It's the middle. So what do we have to do to all the numbers first? You got to put them in order, right? If they're out of order, it doesn't make sense to pick the middle number. Okay, and then we have quartile 1 and quartile 3. Well, quartile 1 is just the middle of the lower half, and then quartile 3 is the middle of the upper half. Okay, real quick on the median. Let's say we have sometimes there's 2 numbers in the middle. What do we do then? Add them up, divided by 2. So you average those 2 middle numbers. How do we know when there's going to be 2 numbers in the middle or just 1 number in the middle? You know, if you go in from the outsides. Okay, even number. So if you have an even number of numbers, what happens? There's going to be 2 in the middle. What if there's an odd number? Then there's just 1. Right? All right. So let's look at this set of numbers right here, and we'll create a box and whisker out of it. All right. So below is example of. So what do we have to do to these numbers? Let's put them in order. Okay. So what's the smallest number? 3, 4. Does it each have the same? Does this go up 5, 6, 3 through 12? Nothing skipped? No doubles? Okay, well this is going to be a nice even little box and whisker there. 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 is the highest. Okay, so we rearrange them, put them in order, lowest to highest. Okay, so let's put actually the minimum. Smallest is 3. The highest is 12. We'll put that. Okay, the median. So start from the outsides and just go in, go in, go in. Okay, looks like we have 2 in the middle. I'm going to circle it. I usually circle it. Okay, so what do we do so what's the median? Divide by 2. Or what's the middle of 7 and 8? 7.5. Or again, you can add them up, so it's 15 divided by 2 is 7.5. So 7.5, 7.5. That's the median. All right, so now to get the median of the lower half. Well, do we use the 7 or do we just start from the 6 and then go? Okay, here's what it says. Okay, so first quartile. Oops. Okay, it is the median of the first half of this data set. Do not include the median to be part of any half of the data. So, well, the median is 7.5. So we're going to use the 7. It's not the median, right? Okay, so if you have 2 numbers there that you had to average or whatever, use that 7. Use that number. Use that number. If it ends up you just had 1, then don't use that 1. Just use the next one over. Does that make sense? Yeah. Okay. So, can you grab the door? Thanks. Okay, so yes, we have 2 numbers. So let's start with this one and go in. So it's this. Then we know the lower quartile. Quartile 1's 5. That's the middle and lower. So 5. Let's do the same thing for the upper. So 8, 12, this, that. So 10. That's quartile 3. There we go. Okay, real easy to find, just the medians. Okay, now to sketch a box and whisker, we need to put our numbers on the bottom. So we determine how we want to number these. Well, lowest is 3, highest is 12. Okay, it looks like we could probably start with 3. Okay, 3, and just go up by ones. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And, okay, so box and whisker. So the box part of it, we're going to make with the median, quartile 1, and quartile 3. Okay, they have a bunch of extra little lines here, but let's use this. So median is 7.5. So I'm going to move it up a little bit. So I'll just use these two. I could just use one space there, but so 7.5, that's the median. This will be part of our box. And then quartile 1 is 5. So I'll put that right there at 5. And then quartile 3 is at 10, so we'll do that, 10. And then that makes our box. And so we do this. Okay, there's the box. Perfectly symmetrical. It should be. All these numbers go in order there. Okay, and then the whisker part is the high and the low. So the high is 12, so we put a little dot there at 12. And just draw a line out to the high. And the minimum's 3, so put a little dot there. And there's your whisker. Okay, would you say that this, so there it is, nice and symmetrical. Would you say this is skewed left or right in any direction? No, I think it's just, well, it's perfect because all the numbers just lined up. Okay, I should have made some other numbers in there or whatever, doubled some higher ones. But anyway. So is it skewed left, skewed right, or normally distributed? I'd say it's normally distributed. So in this case, normal. Okay, normally distributed. Okay. So box and whisker really is it's just the medians. Okay, now the next one, we'll turn it over. It's a modified box and whisker. So let's turn it over. Okay. Have you guys heard of a modified box and whisker? Probably not. Okay, real easy. Looks complicated, but it's real easy. All right, so how to modify the graph. Okay, a box and whisker plot could become modified when you indicate if outliers exist in the data set. So what are outliers? Numbers that are deemed to be way higher, just throws things way off. Okay, or an outlier on the low end as well. Okay, in order to determine, an outlier is a value that doesn't follow the pattern of all the other values. Outliers could have a drastic effect on the mean and the standard deviation. Okay, in order to determine whether or not you have an outlier, you must calculate two boundaries. Okay, so that's this stuff. Okay, there's an upper boundary and a lower boundary. Okay, these boundaries are not necessarily elements. It's not one of the numbers within the data set, but there are values that will help you determine if outliers exist. All right, so this looks kind of complicated, but again, it's pretty easy. So we're going to figure out what the upper boundary is, and then if any number in the set of numbers is higher than that, that's considered an outlier. Okay, then we're going to figure out how to find the lower boundary, and if it's outside the lower boundary or lower than the lower boundary, then it's an outlier as well. All right. Okay, and I will go through this when we actually do this problem. Okay, so let's create a box and whisker, a modified box and whisker from this data set. If outliers exist, and we're going to figure out if there's any outliers, we're going to graph it on our modified box and whisker. All right, so here's all our numbers. What do we need to do? Put them in order. Okay, pretty much that's the hardest part of doing these things, putting them in order. So what's the lowest? 1. And I'm going to put it right above these so I can know that I have the right amount of numbers and I didn't skip anything. So 1, and sometimes I cross it out. Okay, what's the next one? 10. So I'll cross that out. We have 12, 12, 12, 3 15s. So 15, 15, 15. Cross, cross, cross.
No, 16.
16. Okay, 16. There's two 16s. There we go. 16. 17. 18. 19. 20. 19. 20. 19. 20. 21, 25, and 42. 25 and 42. Okay, there you go. Believe it or not, that's the hardest part. Okay, so let's go ahead and do our 5-number summary, and then we'll figure out the upper and lower bound and see if there's any outliers. Okay, so let's work up here. We have a little bit of room. Okay, so we have a minimum, we have Q1, we have the median, we have Q3, and we have a max, or a high number. Okay, so what's our minimum? 1. What's our max? 42. Okay, what's our median? Let's find the median. So go in and find the median. So is it just one number? Okay, so 16. I bet you there's an odd number of numbers there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. So if you have an odd number, you're going to be left with one in the middle. Okay, so median is 16. There we go. So let's find the quartile 1. So do I use this where my pencil's pointing? No, don't use the median. So if there's just one number, just don't use it. So go in from that. So it's this, 15. There's quartile 1's 15. Okay, let's do the upper quartile, or quartile 3. This. So it's like 20. There we go. So if we wanted to make a box and whisker regular, then there we go, we're set. Okay, let's calculate our upper and lower boundaries to see if, for example, see if 42 is an outlier and see if 1 is an outlier. I would say, yeah, 1's probably, because it's pretty low, and this 42, we just have to figure out what the boundary is and see if it's within that. Okay, so let's do this. So the upper boundary, this is our formula. It's Q3 plus 1.5, and it's always the number 1.5. 1.5 times what they call this interquartile range. Oh, that's a fancy little word. Interquartile range is just Q3 minus Q1. You just subtract those. Okay, so let's do the upper first. So upper. Let's do it right here. So the upper boundary is, okay, so Q3, what was Q3? 20. So it's 20 plus 1.5, it's always 1.5, times, okay, what's the interquartile range? There you go, 20 minus 15, right? 20 minus 15, so 5. There you go. Okay, now this will give us our upper boundary. So what do we do first to multiply? PEMDAS. So order of operations. So this is 20 plus, what is 1.5 times 5? 7.5. So the upper boundary is 27.5. There we go. 27.5. Okay, so if that's our upper boundary, is 42 outside of that? It is. Okay, so that's an outlier. Is 25? No, it's within that, right? Can you have more than one outlier on the upper end? Sure. If you had a 42 and a 41, that'd probably be both be outliers, but just 42 is. Okay, lower. Okay, lower boundary. Well, it's Q1, but then minus 1.5 times the interquartile range. So what do I write? 15 minus 1.5 times the inner quartile, which is 5. Okay, so that's 15 minus 7.5, which is 7.5. There you go. So that's the lower bounds, lower boundary. Okay, so you've got an upper boundary, lower boundary. Anything's outside of those, lower than or higher than, then those are outliers. Okay, so is 1 an outlier? Yes. Okay, so we don't particularly graph those on our box and whisker. So let's start graphing it, and I'll show you how to graph the whisker, actually, and the outliers. All right, so let's go ahead and the median is 16. So how should we write all this, or number this on the bottom? We do have a 1, so we got to take, and we do have a 42. 1, 2, 3, 4, 5. No, that might. We can go by. Well, if we're going up to 42, how about we go by? Well, 4 is kind of. How about we go by 5s? So that'll be like 8 of them, maybe 9 of them. So it looks. Okay, let's go by 5s. Let me start at, because there's a 1, so let me start at 0. 5, 10, 15, 20, 25, 30, 35, 40. Let me put 45 because there's a 42. Some of your problems on the homework, you may go over or outside of that. That's okay. All right, so let's start this box, the box part. So median is 16. Median is 16. Okay, so let's just move it up a little bit. So I'll put it right here. So there's 16. Go. Okay, quartile 1, I'm going to zoom out here a little bit. Quartile 1's 15, so that's the edge of the box there. Q3 is 20, so it's right there. Okay, let's make that box like that. Okay, and then the whisker part is not including any outliers. So 42 is an outlier. And so the very next number in this set of your numbers, your data, that's what you use as your high. Okay, so 25 is within our 27.5, right? So 25, that's my whisker part for the high. And then what's the whisker part for the low? Well, that's an outlier, so 10. So 10, there we go. So minus your outliers, there we go. And then, yes, we do plot the outliers. We just put a little X there. Actually, it says right, it says use a dot or an X, but use an X. Actually, I use a little asterisk, a little star. But 42, right, 42, so I'm going to put a little star right there. So that's an outlier, so 42. And also 1. So go down here to 1. And there's your modified box and whisker. So minus those outliers, that gives you a little bit better picture of what most of the numbers are with your regular box versus having it really stretched out there. Okay? Okay, then you had another thing for your notes. So get that other paper out. Let's look at this. Okay. All right, given the following, so they worked everything out. Here's a 5-number set summary there. For these are, guess, our test scores. Okay, let the class size for the data equal 38. So that means 38 students took this test. So it's 38 scores, by the way, which is an even number of scores when we get down to here. And there they are. There's the median, there's the high, there's a low. Someone failed it, someone got a 98. Okay. Do any outliers exist? Provide mathematical proof. How do we know? Are there any outliers? How do we figure that out? You got to find the upper and lower bounds. Okay, so we could do this right here. Okay, so the upper And then we'll see if 98's within the, right? So the upper, so what do I do? What do I write? 82, what do I do? Minus?
No,
Plus 1.5 times, yeah, now the interquartile range, so 82 minus 68, which is 14? Okay, so 82 minus 68, so times 14. Okay, and then, so help me out here, so 82 plus, what's 1.5 times 14? 21. So the upper boundary is 103, right? Okay, it's 103, so that's the upper boundary. Did any scores go higher than 103? No, 98 was highest, so that's not an outlier. Okay, so let's look at the lower. Okay, so it's 68 plus or minus? Minus 1.5 times this 14 interquartile range. So 68 minus 21, which is 47. There you go. So that's our lower bound. Are there any outliers? At least we know that 41 is lower or outside of this lower bound. So 41, so I'd say yes. I'll put 41 as an outlier. Okay, provide mathematical proof. I'll just put an arrow right there. We found the boundaries. Found the boundaries. Okay. Could there have been more outliers?
Yeah.
Sure, because they really didn't give us all the test scores, right? There could have been a 42 and a 43 and a 44, and it still would have been outside, right? So, but at least from what they gave us, that's an outlier for sure. Okay, B. How many test scores were tested and scored? 38 test scores. Okay, does the value 75 need to be an actual data value in the original set of test scores? So the score is 75%, that was the median. Was there a test score, does there have to be a test score of 75%?
No.
Why not? Because it was even, so it's not. Yeah, you could have had a 74 and a 76 in the middle, average to get a 75. So I would agree. So let's put no. Okay, I guess we'll put there is or there's an even number of scores. So how can I write that? So then there's going to be 2 in the middle. So there's going to be 2 left in the middle. Left in the middle. And you would have to average those 2 to get 75. Could there be a 75 as a test score? Sure, if it was a 75 and a 75 or something like that, or whatever, then there could be, but this doesn't have to be. What if 39 tests were given and 75 was a median? Do we know that 75 is one of these test scores? Yeah. Yes, for sure. So it depends if it's even or odd. Okay, last thing here, suppose Steve McQueen, I think he's an actor from before I was born. That's where Lightning McQueen got his name. Yeah. Seriously. Look up Steve McQueen. And then I think he was in an old movie about race cars. Or street cars, but. Okay, I could be wrong. Oh, I'm off topic, and I'm. Okay, suppose Steve McQueen, who collects race cars, oops. Okay, suppose he currently owns 25 race cars that each have a market value between $15,000 and $129,000. Okay, so he has 25 cars, collects. He then decides to purchase another race car that has a market value of 13,000 something. By the way, that's lower than those. Does that make sense? Okay. So he decides to purchase another for 13,000. So he has 26 cars now. Okay, select whether each of the whether the value of each statistic for the market value of the race cars increases, decreases, or cannot be determined. All right, so he had 25 cars. They all range from 15,000 to 129,000, and he bought a car for 13,000. Okay, what happens to the average price of these cars? Does it go up by adding this car in there? Does it go down, or cannot be determined? Why does it go down? Because there's a lesser value, and you average is going to bring the average down. So I'd say I agree. It decreases. What about the median, the middle priced car? If you can't be determined, will it decrease? Could it decrease? It could. Do we know for sure? No. Why? Because you've got 25 cars. Let's say, and it's probably not, but let's say you have a 50,000 car, exactly $50,000 car, $50,000 car, $50,000 car, all kind of in the middle, 50,000 car. So you go in, oh, 50,000. You add the 13,000, oh, it's still going to be 50,000, right? So it could stay the same. It could go lower, right? So this you can't determine. Mode. Actually, what does mode mean? We never really. The most. Occurs the most common, right? The most. So the mode. See if your brains are working here. So is the mode. So he buys this $13,000 car, adds it to his 25 cars. So the mode, would that increase, decrease, cannot be determined, or something else? City? It would stay the same. Why would it stay the same? The highest one's true. The highest one's.
The lowest that he has is 15,000 and down 13,000.
There you go. So I know there's not another car that's 13,000 in there, right? Does that make sense? So whatever the mode was before, it's going to stay the same. Okay, just because this is not in there exactly. So this is a trick question. We got to add our own column. We'll put the mode. We know for sure it stays the same. Stays the same. So maybe on the test we'll have to put another column there. Okay, standard deviation. So what would happen if we put this into the mix? 13,000. Increases. Do you guys agree, or why, Hayden, do you think it increases? There you go. It makes the spread wider, right? Because it's 13,000 makes it. So I would definitely agree. There you go. Okay, so we know how to do the box and whisker. Just find the medians. Okay, so let's get started on the homework. So get your packets out there. So this assignment, or today overall, we're gonna pretty much work on this and hopefully come close to finishing this. Next set of notes is really short, so we'll spend most of our time just working on this and getting a lot of this done. The hardest part, I'd say, of this assignment is just rearranging these numbers. Okay.